IBESS Water and Aquatic Food Production Part 8 will be the second of two movies on aquatic food production. This movie examines two large topics: strategies for reducing the unsustainable exploitation of fisheries, and the second topic is aquaculture. The significant ideas are: aquatic systems provide a source of food production. Unsustainable use of aquatic ecosystems can lead to environmental degradation and collapse of wild fisheries. And lastly, aquaculture provides potential for increased food production. Here is the first of two slides displaying the outline for the movies available in the Water Aquatic Food Production Unit. Use this slide and the next to find the movie you need for review. This movie is found on the next slide. Here is the second slide outlining the movies available in the Water Aquatic Food Production Unit. This movie is focused right here, and while this will focus on aquatic food production, I want to start with a review of Part 7, the dwindling ocean fish stocks. Here are two IB syllabus statements that I covered in Part 7. Let me review dwindling fish stocks as a lead-in to the strategies that mitigate the unsustainable exploitation of aquatic systems. The first is: demand for aquatic food resources continues to increase as the human population grows and diet changes. And the second is: developments in fishing equipment and changes to fishing methods have led to dwindling fish stocks and damage to habitats. This graph shows you Atlantic codfish harvest over time, and you can see that the Atlantic codfish harvest climbed rapidly around 1970. But after 1970, the harvest experienced a sharp decline with a small rebound and then a complete collapse in 1992. This is just one example of many oceanic fish stocks that appear to have collapsed. New England ground fish production, halibut particularly, declined after the 1980s. This graph shows the global wild capture fish production with its curve in blue, and it shows the energy invested by fishermen to capture fish in the open ocean, and the curve is in orange. Now, the quantity of fish captured wild leveled off after the year 1990, despite an increasing amount of energy invested by fishermen. Fishermen were fishing harder, but not getting more for their effort. The oceans were overfished. This graph suggests that nearly 40% of the global stocks of fish are collapsed, with a nearly 80% stock collapse by the year 2030. Now, fish are not farmed in the way that we farm terrestrial animals, such as sheep, cows, or pigs. Sheep, cows, and pigs are bred in captivity under intensive breeding programs so that they are replaced in the same numbers that they are harvested. Humans rely on natural breeding patterns in fish populations to replace the fish that we harvest. The world's fish stocks are at the brink of collapse, with only 23% of the stocks underexploited or just moderately exploited, as compared to fully exploited, overexploited, or depleted. In this graph showing fish production over time, there is much to explore. Notice the increase in the size of the human population, shown as this orange shading along this axis. Notice how the total marine catch from wild fisheries, seen as the blue dotted line, leveled just below 100 million tons in the early 1990s. So the human population continued to grow while the harvest of wild capture fish leveled. This would translate to a declining per capita consumption of fish, but the per capita consumption of fish remains level, and this is because aquaculture has increased to make up the gap. Aquaculture has filled the gap between a growing human population and a leveling of the wild capture fish. So that brings us to these IB syllabus statements. unsustainable exploitation of aquatic systems can be mitigated at a variety of levels through policy, legislation, and changes in consumer behavior? And can you evaluate strategies that can be used to avoid unsustainable fishing? Let's start with strategies that mitigate unsustainable fishing at the international level. So hear that, international level. The International Whaling Commission sets regulations on whaling. CITES is the IUCN Convention on the International Trade of Endangered Species. A CITES Appendix A species cannot be traded under any circumstances. And the Red List, the IUCN Red List, clearly communicates when a species is in danger of extinction. The International Whaling Commission, the IWC, is an international body set up in 1946 to provide for the proper conservation of whale stocks and thus make possible the orderly development of the whaling industry. In 1982, the IWC adopted a moratorium on commercial whaling. And currently, Japan, Russia, and a number of other nations oppose this moratorium. The IWC does allow whaling quotas for native populations, harvesting at a subsistence level. Japan issues scientific permits for whaling, and Norway and Iceland harvest whales under objection to the moratorium, and they issue their own quotas. One last thing, in 1994, the Southern Ocean Whale Sanctuary was created by the IWC. Quotas can be set by international bodies or by national governments. Quota units are ultimately sold to fishermen. Now, monitoring what the fishermen harvest, in other words, monitoring those quotas, is quite difficult. Many fish are harvested illegally, beyond the quota numbers. Remember, monitoring the open ocean is very difficult due to its vast size and depth. In this graph, you can see the quotas for North Sea cod in blue are set below the stock size in red, except for the year 2002. Setting the quota below the stock size serves the sustainability of the fishery. In this graph showing data on the bluefin tuna, the green line displays the bluefin tuna quota in 1,000 metric tons per year. The red line indicates the most likely catch levels. Now, the orange bars represent the actual catch as a percent of the quota. Quotas are being exceeded because it's difficult to monitor the open ocean due to its vast size. Now, satellites can track fishing vessels to ensure legal fishing, but this requires satellite technology, and it's expensive. Here is a satellite image in the South China Sea showing vessels from different countries. Here are two images that are representations of satellite photographs of India here on the left and Sri Lanka on the right. At 2 in the afternoon, the Indian fishermen are within the economic exclusion zone of India, but by 10 p.m., the Indian vessels had encroached on Sri Lankan waters. This is the kind of activity that results in overfishing. The Marine Stewardship Council is an international non-profit organization established to address the problem of unsustainable fishing. The MSC works to promote a sustainable seafood market through a certification program that recognizes sustainable fishing practices while serving to influence the choices that people make when buying seafood. Certification requires analysis of the stock by the scientific community, processed through government regulatory bodies, coupled to consistent monitoring of the stocks. Now let's look at national level strategies, rather than international level strategies, that mitigate unsustainable fishing. In the U.S., the National Oceanic and Atmospheric Administration, NOAA, has programs to monitor fish stocks. Governments set up quotas and exclusion zones along the coast. Again, monitoring or regulating fishing in the open ocean is expensive and it's difficult due to the size of the ocean. In this map, you can see scallop and halibut closure areas off the northeast coast of the United States. The Northeast Canyons and Seamounts Marine National Monument is a marine national monument of the United States off the coast of New England on the edge of George's Bank. It was created by President Barack Obama in September 2016, and it is the first U.S. national marine monument in the Atlantic Ocean. The area is home to rare and endangered species including sperm whales, fin whales, and sea turtles. Here is a relevant IB syllabus statement. Consider how two different fisheries are managed for sustainability. Refer to the use of quotas, the designation of marine protected areas, in other words, exclusion zones, and restrictions on the types and size of fishing gear, specifically the mesh size of nets. Now, I've already spoken to quotas and the designation of marine protected areas. Now let's look at the gear, the mesh size of nets. Nets can have different mesh sizes. Choosing the right mesh size for the fish of interest can serve the sustainability of fisheries. Technologies such as alarms and pingers can prevent threatened species from being caught by the nets. Now let's look at local and individual level strategies that mitigate unsustainable fishing. These would include the work of the local aquarium, the use of social media, boycotts, protests, and the choices that people make about the seafood they buy. These are local and individual level actions to mitigate unsustainable fishing. Remember, we are examining this IB syllabus statement. Unsustainable exploitation of aquatic systems can be mitigated at a variety of levels: the international, national, local, and individual, through policy, legislation, and changes in consumer behavior. Consumers can be educated and aware, thus making conscious decisions based on fish certification. Making sure that consumers choose the right species serves to mitigate the unsustainable fishing of other species. And local protests serve to let government know that people care about sustainable fisheries. With that, let's shift our attention to aquaculture as a fish food production system. Here are the relevant IB syllabus statements. Aquaculture has grown to provide additional food resources and support economic development, and aquaculture is expected to continue to rise. Explain the potential value of aquaculture for providing food for future generations. As I've mentioned previously, the quantity of wild capture fish topped out just below 100 million tons in the late 1990s, and the total did not increase despite an increase in the effort made by fishermen. There were more boats, higher technology, pushing further out into the open ocean, and none of this provided more fish, but instead simply served to deplete existing stocks. Now, as the increased demand for fish was not adequately met by the wild capture fish, the aquaculture industry makes up for market demand. So let's be clear here. Here's a definition of aquaculture. It is the cultivation of freshwater and marine resources, both plant and animal, for human consumption or use. Aqua farming is the farming of fish, crustaceans, mollusks, aquatic plants, and algae. You'd probably be surprised to learn that farmed fish production has nearly eclipsed beef production in tons harvested per year. As wild capture fisheries stopped increasing production in the late 1990s at around 100 million tons, aquaculture increased so that the total fishery production has reached nearly 150 million tons per year. As you can see in this graph, published by the Food and Agriculture Organization, FAO, farmed fish production is expected to grow as wild capture production decreases. Farmed fisheries can operate in sheltered coastal waters, in rivers, lakes, and ponds, or in enclosed bodies of water such as tanks. This is an inland freshwater pond in a developing country. Again, here's an inland freshwater pond in a developing country. Of the different global food production systems, aquaculture is widely perceived as important in the global fight against malnutrition and poverty, particularly within developing countries. Aquaculture is regarded as an important provider of much-needed high-quality animal protein and a provider of employment opportunities. Here is an image of marine aquaculture, crustaceans, lobsters. Remember, aquaculture includes the farming of many different kinds of species. Here is a photograph of the marine aquaculture of sturgeon. Marine aquaculture requires access to the ocean, it requires technical knowledge, and the feed can be quite expensive, as it is typically fish meal. There are environmental issues in aquaculture. More on that later. Aquaculture has been the world's fastest growing food production sector for nearly 2 decades, mostly in developing countries. If shark can be farmed, then the pressure on wild species would be less. This would serve to conserve wild species. You can see how technological aquaculture can be in this indoor aquaculture facility. The fish in this image are sturgeon. Sturgeon eggs are better known as caviar. Marine aquaculture is technological in nature. Submerged cages are used to hold large quantities of fish, but think about how huge quantities of fish in cages might prompt environmental issues. Here is a photo of aquaculture of salmon in Norway. Norway produces more farmed salmon than any other country. Farmed salmon production 25 years ago only represented 10% of the total volume of salmon produced, whereas now farmed salmon accounts for over 70% of the salmon market. Here is an image of aquaculture pens in Qatar in the Middle East and in Greece. The food used to feed the fish in aquaculture is often fish meal, other fish, often the bycatch, the species who were not intended to be caught during wild capture fishing. Now, I want you to consider the following 3 issues about fish meal as the food for aquaculture fish. First, the cost. Fish meal, or fish as food to the aquaculture system, is expensive. Secondly, consider the consequences for wild ocean species. Will humans continue to put pressure on wild species to satisfy the demands of aquaculture? And 3, if we use fish meal to feed our aquaculture fishes, this is less energy efficient. Remember the 10% rule. With each successive trophic level, energy is lost from the system as heat. And lastly, fish aquaculture tends to be less energetically efficient relative to terrestrial farming. Keep this in mind. Here is an aerial photograph of shrimp farming in Asia. Aquaculture has become big business. Now keep in mind that aquaculture involves many different species, including plants, and that marine animal aquaculture holds less of the market share than freshwater animal aquaculture. And I want to make a note of the fact that for many rice farmers, rice paddies can serve as pens for fish. Note the efficiency of having rice and fish grow together in terms of the cycling of nutrients from fish to plant and back. Again, just keep in mind that fish can be farmed alongside rice and other grains. And with this cartoon, let me introduce the environmental issues of aquaculture. You can see aquaculture represented in the cartoon. Tell the world what's happening here. And note the single lone individual in the open ocean. Oceans have been overfished. And note the word quarantine. So that brings us to this IB syllabus statement. Issues around aquaculture include the loss of habitats, pollution, including feed, anti-fouling agents, antibiotics, the spread of disease, and escaped species, and that includes genetically modified species. You can see in this image the extent to which a natural marine area just offshore has been converted to an aquaculture farm. Aquaculture projects disrupt natural habitats. The high concentration of fish in one location, typical of aquaculture, creates pollution. The high load of food and feces adds organic matter to the water, contributing to what's called biofouling, or eutrophication. Biofouling is the degradation of waters due to the high density of fish. Biofouling usually involves microorganisms that alter the quality of the water and they affect the health of the fish. Biocides are chemical substances that can deter or kill these microorganisms that are responsible for biofouling, but the application of biocides is a pollution in itself. Fish that have escaped from the aquaculture pens pose an environmental problem if they are non-native or genetically modified. Non-native species often outcompete local species, driving local species to extinction. Similarly, genetically modified species might outcompete local species due to the introduced genetic characteristics. In this image, we can see the impact of introduced genes. This large fish has genes inserted into it, genes that come from the Arctic pout, and these genes produce growth hormones. The genetically modified salmon have shortened reproductive cycles and are 11 times heavier in the same amount of time. You can imagine how competitive these genetically modified fish would be in the open ocean. You can see the environmental issues of aquaculture here. Escaped fish, fish waste, biofouling, interested predators that might become entangled in the nets, and diseases that escape into the local waters. As well, there are drugs and chemicals used in marine fish farms. Some are hygiene products for disinfection or for environmental control, anti-fouling agents for the fish cages, and some are medicinal products, mostly to prevent disease. Inevitably, when drugs and chemicals are applied to farmed fish stocks, a significant portion of those drugs or chemicals will not reach the target species, but will enter the environment. And while I've already mentioned it, don't forget that another environmental impact of fish farm would be the spread of disease. The high density of fish increases the probability of infectious spread of disease, and those disease organisms can spread into the open ocean or local waters. Spend some time studying this slide. Here is a list of environmental impacts of aquaculture. Take notes from this slide and review the last 7 or 8 slides to gain control of this detail. This slide presents an interesting model for aquaculture. The model displays the farming of various species in a way that mitigates some of the environmental impact of introducing high quantities of food and feces into the environment. These fish release their waste. These decomposer, detritivore organisms reduce that waste, and the currents take those nutrients to photosynthetic algae, which take up that waste. Spend some time studying this slide. The information here suggests that no drugs or chemicals be added to the system. Now, the rapid expansion of the aquaculture industry is having a significant impact on marine ecosystems. As the industry expands, it requires the use of more drugs, disinfectants, anti-foulant compounds, these biocides, to eliminate the microorganisms in the aquaculture facilities. The use of biocides in the aquatic environment has proved to be harmful, as they are toxic to the marine system. And that brings us to the end of IBESS, Water and Aquatic Food Production Systems, Part 8.